Hi, chemistry. We're going to take a couple minutes here and talk about acids. So, you probably have some experience with acids, and acids are fascinating compounds. They are really useful. They're used all over the place. They're in your house, they're in the grocery store, they're in your car, they're all over the place. And so, as you start to deal with acids, really natural questions come up like, why does vinegar or lemon juice hurt if you get it in a cut? Why does your tongue start to hurt if you eat too many Sour Patch Kids? Why is opening a car battery dangerous? Why does vinegar make baking soda bubble? There's so many questions that come up as you start to look into and deal with and research acids. Why can you clean your kitchen with vinegar? Why does that work? It all comes down to the chemistry of acids. And actually, more than that, it comes down to a little magical ion that is the part of every acid. And that little magical ion is H plus. That's the hydrogen ion. And the hydrogen ion is made when you take a hydrogen atom and remove one electron. So let's take a look at that. If we take the hydrogen atom that has one proton and one electron, if we remove that one electron, all we're left with is a proton, right? So sometimes we call it the hydrogen ion. Sometimes we just call it a proton. And as you go forward in chemistry, you're going to see that this hydrogen ion always reacts with water a certain way and forms another ion. But for now, let's just focus in on this one ion. The hydrogen ion, also sometimes called a proton. So every acid is made up of a hydrogen ion. Every acid is always made up of a hydrogen ion that's attached to an anion. And then those two things are actually balanced so that their charges are equal. Again, they're going to be balanced so that the positive charges of the hydrogen are equal to the negative charges of the anion. So you're always going to get a subscript here next to the hydrogen that is used to balance out those charges. For example, HCl, that's hydrochloric acid. It's made from the hydrogen ion and a chloride ion. Notice that there's the same number of positives as negatives. Same thing with H2S. We're going to get two hydrogen ions with one sulfide ion, and that is the hydrogen sulfide hydrosulfuric acid. You can have acids that are formed with polyatomics as well, like H3PO4. This is phosphoric acid. It's made when you mix 3 hydrogen atoms with one phosphate ion. So notice every single acid is going to involve a hydrogen ion, and that's actually how you recognize acids as well, because the compound starts with a hydrogen. If you find a compound that starts with a hydrogen, it's an acid, or at least it can act as an acid. And this little hydrogen ion, this magical hydrogen ion, is what causes all of these properties that we see. That hydrogen ion, that lone proton floating around, is really, really, really reactive. If you find hydrogen, just the element of hydrogen, right, it actually has a pretty high electronegativity. Its one electron is attracted to its nucleus pretty strongly. If we look at Coulomb's law and we look at the force of attraction, that's proportional to the nuclear charge over distance, right? Hydrogen really doesn't have a very high nuclear charge, but it really has a very, very, very low distance between the proton and that one valence electron. And so because the distance is so small, it makes that force of attraction pretty large. So if you look at the electronegativity of hydrogen, it really has a high electronegativity. Which means if you take that electron away and you just have that one lone proton floating around, which is what the hydrogen ion is, that one lone proton is going to go seeking electrons, and it's going to fight for those electrons to rip them off of anything it possibly can find to rip them off of. So when it comes in contact with something that has electrons to give, it's going to be super attracted to that other thing. If we look at like hydrochloric acid, for example, if we mix that hydrogen ion with the chloride ion, right? That chloride ion is super full of electrons. Well, that proton that is now the hydrogen ion is going to be super, super attracted to those electrons. And it's going to form a really strong attraction there. And that's what gives acids its punch. That little ion is what causes all of these characteristics. Why does vinegar and lemon juice hurt when you get it into a cut? Because you're putting a proton, lone protons floating around by themselves, into your skin cells. They're going to go seeking electrons, and they're going to pull those electrons off of stuff like bacteria that's in your cut, which is great because it kills the bacteria, but also off of your skin cells. And that's why you feel the hurt. Why, after you eat too many Sour Patch, does your tongue start to hurt? Well, because those hydrogen ions are attacking the electrons that are in the cells on your tongue. Your tongue cells are being attacked. And the citric acid that's in Sour Patch Kids is going to attack your tongue cells and actually kill them off a little bit. And then your tongue starts to hurt. And it's like, hey, man, back off. Maybe don't eat so many Sour Patch Kids. Car batteries have sulfuric acid, H2SO4, and actually super concentrated sulfuric acid. So there's a lot of these little hydrogen ions floating around. And if you get that onto yourself, it's going to give you a chemical burn. So it makes car batteries, the inside of car batteries, pretty dangerous. You never want to try and open one of those. Okay, so let's take a little bit closer look at acids in terms of what type of a compound is it. Now, we kind of talked about how they act and how they form, but let's look at an acid. Let's go back to hydrochloric acid. What type of a compound is it? This would be a good time to pause your video and see if you can classify it. Is it ionic? Is it metallic? Or is it going to have a covalent bond in between that hydrogen and that chlorine? And if you said that is a covalent bond, you are correct. Hydrogen's a nonmetal, chlorine's a nonmetal. That's going to be a covalent bond. Now, hydrogen and chlorine do have a difference in electronegativity. So these two electrons here in the bond aren't going to be perfectly shared between them. They are going to be pulled a little bit towards chlorine because chlorine is more electronegative. But chlorine's not going to be able to pull those electrons all the way off of hydrogen. So those electrons will be shared between hydrogen and chlorine, which makes them a covalent compound. However, when you name acids, acids are not named like a covalent compound. Acids are so prevalent and so important to industry and to different applications of chemistry that acids actually get their own naming system. So we talked about an ionic naming system, which includes bases. Bases are ionic compounds. We talked about covalent naming systems. And now acids which are covalent compounds, they actually get their own naming system. So let's talk about what that system is. You're going to recognize an acid because it's going to start with an H. Any compound you come across that starts with an H is an acid and can be named as an acid. When you name acids, you're going to base the name off the name of the anion. And so the names of the anions are going to fall into two categories. The name of your anion can either end in "ide" or it can end in "ate" and "us." So things that end in "ide," for example, would be HCl. The anion that is attached to hydrogen is chloride. When you name an acid that involves an anion ending in "ide," you're going to take the "ide" ending off and you're going to add hydro to the front and ic to the back. So an anion ending in "ide" actually gets a prefix and a suffix. So this acid right here would be hydrochloric acid. Now, if your acid's ion starts with "ate" or "us," you follow a slightly different system. So for example, HClO3, this anion is chlorate. Or HClO2, this anion is chlorite. Oops, sorry. I need to fix this. I didn't mean "ate" or "us." I meant "ate" or "ite." There we go. Okay. So HClO3, its anion is chlorate. HClO2, the anion is chlorite. So if you have an anion that ends in chlorate, you're going to take the "ate" off and just add "ic." Notice there's no prefix in this case. So HClO3 is chloric acid. If it ends in "ite," you're going to take the "ite" off and you're going to give it the ending "us." So HClO2 would be chlorous acid. Okay, so it takes a little bit of getting used to because you have to figure out what the name of the anion is before you can name the acid. But if you follow this system, you will learn to name acids. Let me give you a couple more examples. Let me give you H3P, H3PO4, and H3PO3. All three of these are acids. They all start with hydrogen. They're all hydrogen attached to an anion. So pause the video here and see if you can name these acids. All right, so H3P, the anion is phosphide. And so we're going to give it the prefix and the suffix. So this would be hydro is our prefix, phosphor, and then instead of "ide," I'm going to have "ic." Hydrophosphoric acid. H3PO4, the anion is phosphate. Ates don't get a prefix, so I'm going to name it phosphor, and then instead of phosphorate, it becomes phosphoric acid. H3PO3, the anion PO3 is going to be phosphite. So the phosphites don't get a prefix. I'm going to name it phos, for, and then ite becomes us, phosphorus acid. And there you go. The one other catch here is if it comes with a prefix, you keep it. So like HClO4, the anion there is perchlorate. So again, 8 becomes ic. So now I have perchloric acid. Okay, it's a lot of information. You're going to get better at this as you try it. So go ahead and try it. And as you run into questions, jot those down. Let me know what your questions are. We will practice this together. I will see you in class.